Hello, everyone. I'm Steve,
And I'm Scott.
and together we're Backyard Musings. I'm broadcasting from Apple Valley,
And I'm still in Utah.
and we are the Science and Technology channel, bringing you all things science and technology. Yesterday, interesting subject on hydrogen splitting using microwaves. That was really interesting. Got a good one here for you, too. Scientists have long struggled to accurately predict solar flares, but a recent breakthrough using NASA's Solar Dynamics Observatory has uncovered a promising new sign: flickering coronal loops. These arch-like structures in the sun's atmosphere show erratic brightness fluctuations just hours before a flare, potentially providing a much-needed early warning system with the potential to predict flares with significant accuracy. This discovery could revolutionize how we protect astronauts, satellites, and power grids from hazardous space weather. Would you like to know more?
So before I read my thing, this solar flare thing raises its ugly head every once in a while, right? I mean, it's going to be the end of all end alls. It's going to take out
A
our
solar
grid.
flare?
Yeah, it's going to take.
Yeah, it could. A big
take
one.
out our grids, which we know that if that happened, it would be catastrophe, chaos. But all right. So for many years, scientists have struggled to accurately predict solar flares, powerful bursts of energy from the sun that can send charged particles racing through the solar system. Now, using data from NASA's Solar Dynamics Observatory, researchers have discovered flickering loops in the sun's atmosphere known as the corona that may serve as an early warning sign of an impending solar flare. This discovery could help NASA and other organizations protect astronauts, satellites, and ground-based technology from the potentially harmful effects of space weather. So,
yeah, when you think of space, you don't think of space weather, but these rays, the solar rays are. The research team led by heliophysicist Emily Mason from Predictive Sciences Incorporated. I didn't know that was a job title, heliophysicist. That's pretty neat. In San Diego, California, focused on coronal loops, arching structures that extend from the sun's surface. These loops form a magnetically active regions, the same areas where solar flares originate. The team looked at coronal loops over 50 strong solar flares, analyzing how their brightness in extreme ultraviolet light varied in the hours before a flare compared to loops above non-flaring regions. Like flashing warning lights, the loops above flaring regions varied much more than those above non-flaring regions.
okay, so this is a quote. We found that some of the extreme ultraviolet light above active regions flickers erratically for a few hours before a solar flare. That was quoted by Mason. The results are really important for understanding flares and may improve our ability to predict dangerous space weather. And that was published in the Astrophysical Journal Letters in December of 2024 and presented on January 15th, 2025 at a press conference during the 245th meeting of the American Astronomical Society. The results also hint that the flickering reaches a peak earlier for the stronger flares. However, the team says that more observations are needed to confirm this link. So
promising.
But they're on it.
Yeah, other researchers. Yeah. Other researchers have tried to predict solar flares by examining magnetic fields on the sun or by looking for consistent trends in other coronal loop features. However, Mason and her colleagues believe that measuring the brightness variations in coronal loops could provide more precise warnings than those methods, signaling oncoming flares 2 to 6 hours ahead of time with 60 to 80% accuracy.
A lot of the predictive schemes that have been developed are still predicting the likelihood of flares in a given time period and not necessarily exact timing, said team member Seth Garland of the Air Force Institute of Technology at Wright-Patterson Air Force Base in Ohio. This is quoting Carrie Kanuski.
Yep.
Each solar flare is like a snowflake. Every single flare is unique. Okay.
All right. So another quote from Kara. The sun's corona is a dynamic environment, and each solar flare is like a snowflake. Every flare is unique. She's a graduate student from the Air Force Institute of Technology and lead author of the paper. Quote, we find that searching for periods of chaotic behavior in the coronal loop emission rather than specific trends provide a much more consistent metric and may also correlate with how strong a flare will be.
I didn't even know we had an Air Force Institute of Technology.
Yeah, I didn't know that either.
The scientists hope their findings about coronal loops could eventually be used to help keep astronauts, spacecraft, electrical grids, and other assets safe from the harmful radiation that accompanies solar flares. For example, an automated system could look for brightness changes in coronal loops in the real-time images from the Solar Dynamics Observatory and issue alerts. That would be good.
Yeah.
Shut down the grid or whatever, yeah. Previous work by other researchers reports some interesting prediction metrics, said co-author Vadim Uritsky of NASA's Goddard Space Flight Center in Greenbelt, Maryland, and the Catholic University of Washington in D.C. We, again, quote, we could build on this and come up with a well-tested and ideally simpler indicator ready for the leap from research to operations. So,
yeah, so this looks promising. Set up little detectors to find out when the flare's coming.
yeah, this would definitely make things better, definitely. So, I mean, I've heard. I mean, I'm definitely not anywhere an expert on solar flares, but I've heard a lot of people that have been very concerned about that over the years. So, but it's like an earthquake, you know.
Yeah.
If it happens, you're just gonna have to deal with it. So, but yeah, this would be great if they could come up with some kind of early warning mechanism. So, cool
Okay,
story.
folks. Thanks for joining us. We'll catch you on the next one.
Take care. Thank you.